Hello, hello, can you hear me? Good afternoon. Good afternoon, guys. Can I hear you? Yeah? Thank you. We are a small crowd here. We can talk to each other, right? Okay, so guys, thank you very much for the time. Thank you, Zebra team, for the invitation. For me, it's a pleasure to be here representing Qualcomm. My name is Douglas Vaz Benitez. I'm responsible for business development in Europe, part of the BD team in EMEA. And for us, it's a pleasure to be here. I don't see you much, but I trust you are there because I see some shadows over there. So we are going to have a session this afternoon, talk a little bit about Qualcomm. We'll discuss a little bit about our view on the digitalization of industries, how we see the edge, how we see the evolution of AI, how AI is going to be massive. And I hope I'm not an enhancement of your desire to go to a siesta after the lunch. So hope you stay with me. Okay, so we truly believe that digital transformation is coming, it's a reality, and it really drives demand for our products. This is truly a moment where we see the industry digital transformation picking up, and it's super exciting to see how the companies are adopting our technologies. We see the digital transformation in three main pillars. So we see it as edge networking IoT, but also on the consumer and enterprise IoT. So each of those three pillars, we have a role. So we play a part in enabling or helping the digitalization of enterprises to happen. So for instance, in the case of edge networking, we are powering network solutions like edge boxes, like FWA solutions. We are bringing technology to connect devices to cloud. Technologies like 5G, like Wi-Fi, and like many others. We also have a play in the enterprise IoT, where our technologies are bringing applications like robotics, like industry automations, like drones to life. So this is something that we do very often with our enterprise partners, and we are very excited as well with the role we are playing in the enterprise IoT. Like retail, energy, logistics, transportation. There are many, many, many industries where Qualcomm is actually influencing with our technologies. And on the consumer IoT, maybe it's where we are more known from our past and present on smartphones, where we see our technology flowing to a multitude of IoT devices in the hands of consumers, like the watches, like you have one in your, I don't know if you are smartwatches users, but you are likely there may be some Qualcomm technology in your wrist, like earbuds. We can see like consumer drones. We can see in XR devices. By XR, I mean virtual reality, augmented reality type of devices. You see Qualcomm technology in the PCs. You see Qualcomm technology in a bunch of devices in the hands of consumers. So this is a very, I would say, privileged position to have, which makes Qualcomm a natural partner for cloud players in the edge. So we are a kind of a natural edge partners for the cloud providers. And we have inner qualities. Well, this is a kind of a propaganda slide. I think you're fine with that, right? So we have three things that is very unique to Qualcomm, that we bring in every single technology that we have. There are those three things that I listed in the slides. We bring advanced connectivity. So Qualcomm, from our history, we are bringing 3G, 4G, 5G, Wi-Fi 6, Wi-Fi 7, Bluetooth, Bluetooth LE, so on and so on and so forth, to the bunch of connected devices. And we are always evolving the technology in order we are always striving to bring the best connectivity possible for our clients, for our users, and for the industries. The second thing we have is high power, high performance, low power compute. This is inherent to Qualcomm because we were born in the mobile space, right? So in the mobile space, what we don't have? We don't have an electric power cable connected with us wherever we go, right? So we have a smartphone that relies on its battery, and the compute capabilities needs to consume the less possible power from your battery. So we learn to balance compute capabilities with low power consumption. And that's something that we are doing across all industries, especially now with the climate changes, green technology, green energy, so on and so forth. This is becoming paramount. It's also driving a lot of traction toward technology. So everything here for the IoT, we believe needs to be low power, but high performance. And that's something that we have been doing from the foundation of the company. And third, on-device artificial intelligence. We believe on-device AI is super important because there is no way we handle all the AI tsunami that is coming relying only on the cloud. Maybe my Google friend will disagree with me, or maybe not, because it's truly impossible we handle that just with the cloud. But so we are bringing on-device AI. So these three things that are unique to Qualcomm that we are working for so many years put us in a position to offer to the ecosystem, like partners or developers, to build virtually any use case you can come up. Because we have the compute capabilities, the low power consumption, the connectivity that you need with AI in the edge that can really enable any use case. So if you are a developer, you really have something in your hands that you can leverage upon. And we are very proud on this. So when we see the evolution of this market and how the AI will be pervasive and really scale, we see a movement that is bringing closer to the edge AI capabilities. As I was telling you, it's very difficult for us, it's going to be very difficult for our industry to handle all the massive data demand that will come with AI. So we truly believe in distributed AI processing. So there has been some publications, like one ChatGPT question consumes 10 times more energy and resources than one simple Google answer, question or research. When you go like the Google bar and you make a question, it consumes 10 times less. So ChatGPT, for instance, they spend $700,000 a day just to maintain what they currently have. It's a lot of money. So we need to distribute AI. So in order to distribute AI, we need a whole bunch of different partners, and we need many nodes in that chain to make it happen, and one of those nodes is the device. So we are bringing AI to the device and to the sensors. But what happened is not all devices can actually be made intelligent. You have dumb devices out there, like cameras, for instance, analog cameras. So you can bring one step aside, like an edge box, that the edge box brings intelligence to your device. Or you can have nodes concentrated geographically. So what we are doing as Qualcomm, we are providing intelligence across the edge. So we're bringing AI edge boxes, we are bringing infrastructure AI acceleration, and we are bringing on-device AI. And in on-device AI, just as a curiosity, the device can handle the AI processing and the large language models or the infusions in three different ways. It can be solved completely in the device, and we have done a demo recently about it. So we can go offline, airplane mode, ask a question like image fusion. Say, I want you to create, I don't exactly remember what the case was, but you can create a cat with wearing this type of clothes, and the device resolves itself. For more complex cases, you can do some kind of hybrid device network AI. So the device manages the language interpretation, so you talk to the device. It does speech to text. The text is uploaded to the cloud. it comes back to the device, and the device resolves the text-to-speech again. So it's a kind of a hybrid mode, or a full hybrid mode, depending on the case. So we truly believe the intelligent edge is coming, and it's paramount that we have distributed computing across this entire network. And this makes a very exciting time for us, for the industry, and it's a true convergence in what we were talking about: connectivity, computing, and AI. But as I mentioned, it's very difficult to resolve that alone. Actually, it's impossible. There are multiple companies, multiple players, multiple partners that makes that happen. And it's not a role of one, it's a team play. So we have been working with multiple partners in the ecosystems, like distributors, mobile operators, SIs, cloud providers, chipset solutions like us, and some other partners, hardware developers, service providers, module makers, in trying to enable that industry and create as much ecosystem as possible. So what we want to do is help this ecosystem to grow. So we really want to act as a facilitator, so the use cases come in. So we have a direct role on building technology, in enabling research. But once we implement in the chip, we want to also work with the industry and the partners to facilitate multiple verticals and ecosystem to happen. And we are super happy in seeing the traction of some of those technologies coming into life in multiple verticals and use cases. Totally different use cases in a variety of implementations on reach, length. It's very exciting to see some of those things. So just to comment, for instance, in the retail, which is very present to us in this room. So we have POS, we have digital signage, we have people receiving goods, we have cameras, we have sensors telling consumers what to buy, we have digital signage, so lots of use cases in the retail industry. Also, for instance, in the utilities, you see from the complete grid, multiple use cases. So from the smart meter until smart edge boxes that controls parts of the network, from simple tilt post sensors that can identify if that pole has been tilted or has been crashed, which is very difficult today for the industry to understand. You're bringing intelligence to all those sensors. For instance, in the smart cities, where we are bringing traffic management, we are bringing parking systems, we are completely helping industries to digitalize their education. It's all in the smart cities domain. So lots and lots of use cases, like manufacturing, where we're bringing automation, robotics. So we are super proud on the role we are playing in some of our partners' projects. But I want to double-click in something that is even more near and closer to this audience, which is the warehouse management and the logistics. We all know, maybe we already discussed during these days, how this industry has changed, right? We have seen a tremendous acceleration post-pandemic of the e-commerce, and this is transforming the way the warehouses work. We see this with some of our partners. It has been completely turned upside down. Not only the increase of demand, but also the expectation of the consumer to have their goods the following day, maybe the same day. So the expectation is really high. In the same context, you have the multiplication of warehouses, so you can get closer to the customer, so you can really meet these expectations. But in the other hand, you have lack of personnel to do this. So the people you have, you really need to maximize their productivity. So these guys are going really crazy with this transformation. So we just have some examples of technologies that we are bringing in this case. So we have some real-time asset monitoring for them to easily locate where their goods are in the warehouse, for instance. We are also bringing robots to facilitate the goods movement within the warehouse. We have technology to monitor inventory levels, edge AI boxes to improve the location of damages or accident prevention. So there are multiple technologies that we are enabling for this use case that is helping partners and industries to become more effective, to make their workflows more optimized. When you look at the shipment and delivery, same thing. So we have the goods flying around. How do you really control and you track a good end-to-end? So we are bringing technologies to this industry for real precise location of the goods, so you can track your package, fusioning, merging GPS and sensors. We have environmental sensors for critical type of goods. We have AI cameras with 3D ToF that can really enable the safety of drivers, or those works like LiDARs, right? You can really enable safety of drivers, but you can also enable a bunch of different use cases with computer vision in the warehouses. And of course, we enable 5G, Wi-Fi, connectivity, so everyone is connected regardless where they are. So this is something that we are bringing. That's why it makes the partnership we have with Zebra so important for us. And we are super honored and delighted with this partnership, with the devices we are bringing together. So many types of different devices that address different use cases in the day-to-day. So for instance, we have the handhelds in your top left, I'm inverted here. So the top left on the slide. So we have the workers using this in the day-to-day to receive, ship, control, making the inventory the day-to-day. So in the other side, you have also devices for the managers that makes them to be present in the floor, close to the team, collaborating closer to that team. So we have them at the same time connected to the warehouse management systems. So being present, but also being connected. This solution, I really like it, the hands-free solutions that you're building for picking, for sorting, replenishing. So you have your hands free while you're doing everything. For repetitive tasks, this is very important, and also for the truck mobility. So we are super proud. So with products like the TC5358, TC7378, the ET6 series, so all those phones that carries our technology, we are super proud of it, and we are super happy to see how you are transforming the workflows and making their workflows more effective and optimized in your customers that are using your technology. But this is possible because we have been investing in technology for years. We, until now, invested $85 billion in R&D. That's a figure we are very proud of saying, because we consider ourselves an R&D and a technology company. And I would like to double-click in 4 domains of technology that we believe is super important. Some of them already mentioned. So compute. So if you think of a Qualcomm chip or a Qualcomm platform, we like to be a one-stop shop. You can come, all the technology you have is integrated in this platform. So compute, you will find in our platforms the CPU, the GPU, the NPU. You will find DSPs, ISPs to manage all kinds of technologies and do all the processing that you need, specialized, low power. When you look at AI, machine learning, deep learning, so those are technologies that we have been investing for years as well. You will find this present in our capabilities, not only on our dedicated chips for that, but we do machine learning AI distributed across the chip. So you can resolve things in the GPU, you can resolve things in the CPU, you can resolve things in the GSP, and the large language you resolve in the dedicated chip. We will talk more about it in the coming slides. Security, extremely important. How can you do digitalization without security? So we are super happy with all the security we are enabling in our chips. And lastly, connectivity. Already spoke a lot about connectivity. This is something that's very, very intimate to Qualcomm. We really bring, and we strive to bring, connectivity to everyone, reliable connectivity, whether it is mobile, well, always mobile. I mean, cellular, Wi-Fi, Bluetooth, all kinds of connectivities. So to give you an example how we integrate all this into a platform, we will show you a chip. And we will do this in a very interactive way with my virtual assistant, Gen AI, called JJ. JJ? I'm kidding. He's based in France. He's a true person, and he will discuss a little bit with us. Hey, JJ, tell us a little bit more about the QCM6490.
Buenas tardes. Can you hear me well?
We can hear you perfectly.
Okay. So QCM6490, that's actually the chip which is at the heart of the new Zebra terminals, the TC53, 58, 73, 78. It definitively personifies everything that Douglas has explained in the last minutes. This is a very powerful chipset, especially at the level of communications and AI machine learning capabilities. Performance is first and foremost twice the performance that we used to have in the previous generation chipset that was in the previous generation Zebra product, using an octa-core processor with a GPU which is 5 times more powerful than what you had in the previous generation, as well as dedicated AI processors via a tensor accelerator and vector accelerator. Security, you were mentioning, and it's that's super important for this kind of device, because not only you authenticate your user with biometric authentication, face detection, but you can, for instance, in future applications, enable secure payments. So we have secure processors inside the QCM6490 for this kind of application. Operating system, we are super proud that we have developed that chipset for industrial uses with this capability to have Android, Linux, Ubuntu, and Windows. And most importantly, we are committing on long life for that chipset and long life for that software suite that will allow device manufacturers like Zebra to propose Android updates and security updates for the many years to come, so that your device will always remain on par with the rest of the market. Camera. So the Zebra devices, I know they have camera, they have tough sensors, very important for the kind of applications that Douglas has described previously. So, of course, think of shooting videos, shooting pictures with the same level of high-end mobile phones. We can connect sensors up to 192 megapixels. And think also of all of those industrial usages, like, for instance, in deliveries, detecting if a package is damaged, or maybe shooting an accident if you're a first responder. So this is very important that we offer camera and video, 4K video, especially on par with consumer products. It comes along with very strong display support, like a capability to support 4K displays and a capability to connect external displays through the USB-C plug. And keeping one of the best things for the end, connectivity is really at the top of what you can expect today, with triple band Wi-Fi 6E, as well as 5G standalone, non-standalone, and Bluetooth, of course. There's also a capability to communicate over first responder bands, like the CBRS, as well as the FirstNet in some regions. So that's extremely important for that chipset and the devices using that chipset to be able to use those very specific networks. And finally, I was describing it previously, those very high AI capabilities that make the use cases described by Douglas feasible. And Douglas was describing some consumer use cases, like the capability to automatically generate images. But let's think in a more professional domain of capability for robots using that chip to more intelligently, rapidly, and autonomously detect their surroundings. Or think of the driver attention, the application that Douglas was showing just before. If you want to do those things, it's very important to perform all of those detections locally, because, of course, privacy is important. Network bandwidth is important. So this is the kind of application that local AI makes possible.
Thank you, JJ. So this is a chip that is present on the latest Zebra technologies, but AI, as he was describing, we take the AI approach in 3 different domains, right? So JJ, you can move to the next slide. You will see that we look at the AI as hardware, algos, and software. So it is important that we bring the hardware capable of it, and we are actually enabling state-of-the-art hardware with multiple TOPS to really resolve what is needed on the AI. Truly heterogeneous computing, as I already mentioned, and low power. We are also doing all the research and seeking to enable in our hardware the latest algorithms and making sure it consumes less space and optimizing the runtime of those algorithms. So this is super important for us. And software. So we also look AI as a software stacks. So we bring an end-to-end AI solution to the developers, as AI is becoming increasingly important for any use case. So if we double-click in hardware, JJ, what can you tell us about our hardware implementation? We are on mute, I believe, JJ.
It's a Teams call, always happens. Yes. Hardware, we have quite a long history in AI acceleration at the scale of chip design. And we started back in 2018 by improving the signal processors, the DSP that we have in any processor, by bringing some improvements for the manipulation of large vectors. So we were calling that the hexagon vector extensions. And that was a first step. So using the CPU, the DSP, which had been enhanced, as well as the GPU in starting to have AI applications, we improved that system in 2020, and by bringing the integer 8 and integer 16 support. So that corresponds actually to what Douglas was describing with the research in algorithm support. By avoiding the use of floating point operations to a maximum, and by reducing the precision of the calculations, but at the same time, by demonstrating that the quality of the results of those calculations remain unchanged, the end precision remains unchanged. We brought very high advances in power efficiencies. That's really the key. When you have a mobile device living on a battery, when you have a smart camera or smart edge box, which is without a fan, just with a natural ventilation, it's super important to do things at very low power. Then in 2020, we brought the hexagon tensor acceleration, which was our first dedicated processor for AI manipulations, bringing a capability to manage even higher matrices, even bigger systems, while still having very high performances. And then in 2021, we applied the merge of the two technologies. So we mixed the previous technology of DSP with the once separated hexagon tensor accelerator, and by tightly coupling the memories in between, so that even an operation that leverages both processors is now executed in a better way, in a more fluid way. And we called that improvement the hexagon tensor processor, which is actually the generation of AI acceleration that you get in the QCM 6490 present in the latest Zebra devices.
So what can you tell us about the performance of those hexagon tensor processor?
Okay, so the performance, we usually demonstrate it through standardized benchmarks or standardized algorithms, like the ResNet 50, which is a usual algorithm used for computer vision-like operations. The MobileNet V2, which is an image classification algorithm. So this is the usual question: is that a cat? Is that a dog? As well as the YOLO V3, which is more a real-time object detection system. So that's the kind of algorithm that your picture camera is using to detect your face or to detect that you're smiling at a given moment. So what you see with the different generations of processing that we have introduced from QRB 5165, which was the second generation, through the QCM 6490, which is the third generation, and now the very latest generation, QCS 8550, you see that dramatic increase in performance that we are measuring in inferences per second. So really the capability to do more detections per second. So you see the boom in performance due to the accumulation of all of those improvements, which is also coupled with the improvements in silicon technology. So that's my left-hand side diagram, just the improvement in brute performance. But what comes along at the very same time is what we have on the right, which is the peak power efficiency, which is the improvement in consumption per inference. So of course, in that scale, longer is better. We have inverted the scales. So we are also at the same time improving the power consumed by detection. So really both effects are combined to make new use cases possible on newer mobile terminals.
So again, we are combining high performance with low power. And we have, if you go to the next slide, we have also to think about software, right? So we have great hardware, powerful, optimized for power consumption, but we cannot have a software stack per each vertical that we try to address, right? We cannot have a software stack for the manufacturing. We cannot have another software stack for warehouse and logistics, for retail, for energy. We cannot have multiple software stacks because it is actually impossible, because you cannot actually foresee the multitude of verticals or use cases that you're going to address. So it's virtually impossible. So we need to optimize that. And how do we optimize that, JJ?
So we optimize that by having a unified software stack, which is available to developers to develop their own applications. So the beauty of that tool is that we have the very same tool for all Qualcomm devices. Should you work on consumer devices, should you work on IoT devices, should you work in automotive devices, and should you work on lower tier products or high-end products, you'll be using the same suite of software. So the suite of software contains the deepest elements that you need to compile and run your models, like the libraries, the compiler, the drivers for the accelerators that I described just previously. And on top of that, you'll have runtimes, of course. So that's really the software executing your models in real time. So we support two, actually. We support our own Qualcomm neural processing, which is definitively the most optimized one, and the one which is dynamically capable of distributed your AI loads on all the processors. We have the chip AI processor, but also CPU, DSP, and GPU. And we also support TF Lite, TensorFlow Lite, which is an open source approach for those users who prefer that thing. The kind of models that you can load into the tool, because that's important. You need to find your models and define your models, and we accept models from the three most popular frameworks on the market, which are TensorFlow, PyTorch, and Enrich. On top of that, we have the Qualcomm Intelligent Multimedia SDK, which is kind of a plug-and-play approach to connect all of the algorithms, but also all of the input and output blocks that you have on the processor, because the data that you want to manage via AI, it can come from the microphones, it can come from the sensors, like vibration, acceleration, it can come from the microphones, the cameras. Then it's important to describe how you're going to chain all of the various treatments that you're applying, and that's a functional block approached system based on the open source system called JStreamer that we use for that. So really, that's a toolbox mainly based on the standards of the market, should there be open source or not, and also based on the best knowledge that Qualcomm can have on the way the silicon works to provide the right levels of acceleration.
Very good. So thank you, Jean-Jacques Adragna, staff manager, product marketing, my friend based in France. Thanks for joining. And to conclude, last slide, we have a huge opportunity in front of us. We truly believe we are in the right moment to make this industry happen, solidify. We are connecting things, we are helping our partners to make their products a reality. And if you are a developer in this room, we really encourage you to look at our solutions, look at our SDKs, to join our developer network, because you have a bunch of tools that can help you to develop applications for so many different use cases that you can imagine. Thanks again for the invitation. I'm not sure if we have time for questions in the audience, but for me, it's been an honor to be here with you. And thanks for the time and for the attention. Appreciate it.
Thank you.
I'm not sure if you have questions from the audience. I learned there will be a big prize for those who make a question. Oh, we have one. So there's a big, is the mic there? Oh, yeah.
Thank you. I want to ask about the roadmap and the software stack support for on-device running of ML models and frameworks. We have tried to use this in the past, and we had some challenges to get the whole stack running. So I'm wondering about the level of maturity and kind of your roadmap of improving and expanding this ecosystem. Because, with the age of AI blossoming upon us officially now, like it's out in the wild, I'm wondering how this software ecosystem will evolve.
As this is a very tough question, I'll ask JJ to answer.
So this software is now extremely mature. As I was saying, it is supported on all the chips that we release in Qualcomm. It has several generations, and as it is true that it can be sometimes a bit tricky to access all of the Qualcomm software, Qualcomm designs, and so on. So we have that developer.qualcomm.com website, when it's becoming much easier than it used to be to download software, accept our license agreements by just clicking, and we also have forums where you can report issues or problems. So I believe that the system is now very mature.
We have an internal mandate to become a developer-first company on the software side. So you will see the maturity coming and increasingly for every new release, you will see it's going to be more mature, more stable, and more accessible. You have the mic?
Hi, this is Kaushik here from the company called 42 Gears. My question is somewhat related to the previous question. When you talk about AI, there are basically 3 layers, okay? One is device, second one is obviously the middle layer, and then it comes the presentation layer. Okay, since you said that you are already developing the softwares for the presentation layer, will you be exposing the APIs also for the third-party integration, or it will be 100% solely on Qualcomm?
No, the idea is to expose the APIs, but JJ, please feel free to go into the details.
Yeah, APIs are exposed, and again, I encourage you to have a look at the developer.qualcomm website, download the tools. Douglas, I think we can maybe take business cards or emails in case we...
Absolutely, yes.
Yes, we can follow on with the questions later. So definitively, we are, as Douglas was explaining, we already have the tools. They're extremely mature. They can be sometimes a bit tricky to use, but we have that absolute mandate to be more developer-friendly and propose you more documentation, more access, more standardized APIs. So we have some customers, for instance, asking other open source runtimes than the ones that we support at the moment.
Because here in this chart is just showing the intelligent multimedia SDK, but there are other SDK. There's the Neuro SDK exposing APIs. There are multiple SDKs that expose APIs.
That's fine. Thank you.
And more questions? No? So with that, I think we conclude our session. Should I hand over to... Am I done? So guys, thank you very much. Enjoy the rest of your day and enjoy your stay in Madrid.